Okay, so for this first one here, we're going to prove true for n equals 1. Prove for n equals 1. So the left-hand side is 1 times 3. That's one term. Or you could use that and put 1 in it, and you'll get the same thing. Okay. So, because that's 1 on 1 times 3, which is 1 on 3. The right-hand side is if you use the sum formula, which is that one, and you're just putting 1 in there. 2 times 1 plus 1, which is 1, 3. So therefore, left-hand side equals right-hand side, proven, and it's true for 1. Okay, so now we're going to assume true for n equals k. So that means that if you add all this up to k terms, you get k over 2k plus 1. So if you sum k terms, you get that. So now we want to prove true n equals k plus 1. So you're required to prove that if you add this up, 2k minus 1, 2k plus 1, and you go one more term, so you do sk plus tk plus 1. So you go one more term, so you sum it to k plus 1 terms. What would that be? That would be 1 over 2k plus 1 minus 1. 2k plus, I'm not going to fit that in anyway. So the abbreviated form of that, if you sum it to k plus 1 terms, you're going to get k plus 1. So I'm putting k plus 1 into that right-hand side over k plus 1 plus 1, which is k plus 1 on 2k plus 2 plus 1, k plus 1 on 2k plus 3. So this sk plus 1 just represents adding this up k plus 1 times. So that's k times, and k plus 1 would be one more of those. So to be adding on the k plus 1 term. Like that. Okay. So the left-hand side will equal sk plus tk plus 1. The sum to k from the assumption is k on 2k plus 1. And a term in k plus 1 would be getting this and putting in k plus 1. Like that. So it's k over 2k plus 1 plus 1 over 2k plus 2 minus 1, 2k plus 2 plus 1. So it's k over 2k plus 1 plus 1 over 2k plus 1, 2k plus 3. Now you need the common denominator. We have a common thing here. So all you have to do is multiply this one by 2k plus 3. And the top line would be 2k squared plus 3k. And then this one will be plus 1. And that's all over 2k plus 1, 2k plus 3. Now the top line, this here, should factorise so that you're left with a k plus 1, and you can see the denominator's got to be 2k plus 3. So you'd be expecting that one there to cancel out. So it's 2k plus 1, 2k plus 3. So you could take that and factorise it as a mnemonic, but I can also see that I just need a k plus 1 here and a 2k plus 1. Because if I did that, then this will cancel out and I'll get my required result. So you can nearly, look at the prize and try and work out what it would factorise to. Or you take it and you factorise it. Product equals 2 times 1, which is 2, sum 3, 2k squared plus 2k plus k plus 1. So it's 2k, k plus 1 plus 1, 2k plus 1. K plus 1. So it's k plus 1, 2k plus 1, which is what I got by trial and error and trying to get the prize. So that equals right-hand side. And you've always got to conclude, therefore, by process of mathematical induction, true for all n greater or equal to 1.